Welcome to the class. So today we'll start with the construction of Mohr circle. So let us take one question from this question paper, video question paper, that is December 2016 and January 2017. Here, if you see, like in the module 2, we have question on Mohr circle. We have question on Mohr circle. The state of stress in a two-dimensional stress body is as shown in the figure. We need to determine the principal plane, principal stress, maximum shear stress, and we need to sketch the result. And we need to construct the Mohr circle to verify the answer. For this, we have a two-dimensional plane body which is subjected to tensile stress of 180 megapascal and 120 megapascal along with the shear. For this, how to construct a Mohr circle? Let's start. Let's draw the plane diagram which we have. Let's draw this plane diagram which is subjected to like tensile. It is subjected to tensile stresses at the x and y axis, and it is subjected to shear. Along with this, we have shear. Let us write the values. Here it is 180 megapascal, 180 megapascal, and here it is 120 megapascal, and the shear stress is 80 megapascal. First, we'll write the given data, like what has been given. Sigma x, stress in x direction, which is 180 megapascal. Stress in x direction is 180 megapascal, and stress in y direction, it is 120 megapascal. Then the shear stress tau is 80 megapascal. What are the sign conversion we need to know here? See, if the shear stress is acting to the right side, like right corner here, otherwise you can say like if the shear stress is acting clockwise or anti-clockwise, we will see the sign conversion. Once we'll solve this numerical, then you will understand how to take the sign conversion. Otherwise you will get confused about this. Like here sigma x, it is tensile, so it is positive. Sigma y, it is tensile, so it is positive. Let's see sign conversion of tau xy later. You will get to know once we solve the numerical. Before that, we need to determine the principal stresses. To determine the principal stresses by using Mohr circle, we need to construct the Mohr circle. To construct the Mohr circle, first we need to have we need to take some scale to draw in an appropriate scale. For that, see, both are in tensile in nature. Both are in tensile in nature, so I can take scale around 20 megapascal is equal to 1 centimeter. If I take 20 megapascal is equal to 1 centimeter, then sigma x will be so 180 divided by 20. So we'll get 9 centimeter here. You are getting here 6 centimeter over here, and it will be 4 centimeter. Okay, so how to draw this? Otherwise, you can do one thing. We'll take this is the one method to draw the Mohr circle. Otherwise, we can go with the coordinates. Like here, if you see on the vertical plane, this is the vertical plane and this is the horizontal plane. On vertical plane and horizontal plane, what are my sigma coordinates and shear stress coordinates? In vertical plane, if you see on this vertical plane, we have a tensile stress of how much? 180 megapascal. And we have a shear stress which is acting on this vertical plane, which is in anti-clockwise. So counterclockwise direction, which is nothing but we will consider a positive. So here positive 80 megapascal shear stress which is acting on this plane phi. On horizontal plane, on this horizontal plane, if you see, there is a tensile stress of 120 and the shear stress which is acting 80 megapascal in the clockwise direction. So it is negative 80 megapascal. So first, before we start with this, we need to take the vertical and horizontal coordinates. If you take these vertical and horizontal coordinates, then it is easy to construct the Mohr circle. So to construct the Mohr circle, first what we need to do, we should have the axis x and y axis. Clear? So here, this is our sigma x. This is our sigma x, or you can see this is plus sigma, this is minus sigma over here, this is minus tau, and this is plus tau. These are the coordinates like which we need to consider before construction of the circle. Then once we do this, like make sure that it should be plus sigma, here it should be minus sigma, it is minus tau, this is plus tau. Now here the coordinate, vertical coordinate, first we'll draw vertical coordinate. Vertical coordinate is sigma is 180 and tau is 80. So in tau is plus 80. So here sigma x is 180 approximately. If it is 0, 180 in the sense we need to draw, it is approximately 180 over here. And tau coordinate, tau it is plus 80 in the sense downwards we need to take plus 80 somewhere here, it is 80. So this is my vertical plane. This is my vertical plane. And next we need to draw horizontal plane. Horizontal plane in the sense sigma is plus 120. Sigma is plus 120. 120 in the sense somewhere here it is 120. And here we have minus 80. We have minus 80, that is tau. So minus 80 in the sense here it will approximately here it is minus 80. So this is my horizontal plane. This is my vertical plane. This is the horizontal plane. Now by using scale, you can draw a line which should join these two lines. Now draw a circle from this center as this one. Draw a circle. Draw the circle over here. So this is our Mohr circle. This is the Mohr circle. Now here we need to determine principal stress and principal plane. What are the principal planes here? If you see from this diagram, the principal planes are, these are the principal planes. Sorry, principal stress. From the reference axis to here, if you measure this will be the sigma 2, minor principal stress. From O to the extreme end of the circle, this will be sigma 1, major principal stress. And the angle from here to here, this will be 2 theta P1. Like 2 theta P1 in the sense angle of major principal stress or location of major principal stress. Clear? Next, tau max. How to determine tau max? Tau max is nothing but radius of Mohr circle. Maximum shear stress is nothing but radius of the Mohr circle. If you take the radius, this will be the radius. If you measure this, you will get the radius of Mohr circle as tau max. And if you know the theta P1, if you add 45 degree to this, you will get a theta S1. What is theta S1? Location of shear stress. Location of shear stress. This is how we construct a Mohr circle for the given numerical. So comment me below that like what is the answer you got for this? The sigma 1 major principal stress, minor principal stress along with theta P1, theta P2 and this tau max maximum shear stress. Next you have this theta S1, theta S2. By using analytical method, you give the answer for this. Let's verify those answers. Fine. The answers will be uploaded in the second video. Thank you for watching the video.